Hello friends, going to do a little bit of a training video. Hopefully this will be rather short and to the point. Going to share a screen for, hopefully, here we go. All right, so here's the exam. A couple of students asking questions about the exam. And it says, use a cashier's algorithm that randomly selects a total charge, randomly selects a payment in dollars and cents that exceeds that charge, and then have the program calculate the change in pennies, nickels. Well, all right. So bonus points to anyone who writes the count change back. All right, let's get started. So I like to do things from the terminal. Oh, Windows box. I like to keep things in the SWASU Python examples. Oh, Windows box. CD to discrete structures. Exams. All right, we've got the cashier problem Python. I'm gonna let's do one from scratch. So let's just call this exam 02.py. Oh, need to say, before I do that, since we do have one in here already, I'll open it up and let's take a look at it. All right, print hello. I do that on all of my code. So we'll paste that here and we'll save it. And let's go back here. And that new code does run. Let's see what else we have in here. Okay, in order to make random run later, you have to import the random library. And because I've screwed up smaller things than that, we'll check it. All right, the next thing it says is generate a random number between a given positive and a positive range. Okay, so total dollars and total cents, we've got this. Cool. So we're going to have this is a floating point number, this is a floating point number. We're going to add the two of them together, and then we're going to print it off. And it looks like I must have used this reference from kite.com to do that. So let's just go see. Oops. See how that works. So total dollars, total cents, and our total. Let's see if this runs. Okay, $1.02, $9.37, $48.93. So, I mean, it does seem to have some good variance to it, and it does seem to go around pretty well. Cool. So that part seems to make pretty good sense. Let's just grab this little line of code. Oh, I keep forgetting. I gotta move it over first. So the next thing we're going to do is we're going to do kind of the similar thing that we did for making our total, and we're just going to do this time we're going to do total plus 100. So what this means is the least our random number could be is what our previous total was, which is up here on line 12. And the most it can be is $100 more than what our initial total was. So that means we're always going to have between no pennies and $100 bill for change. Okay, and then oops. Wow. Oh, I see. And then we're going to have change, which is going to be equal to our payment minus our total, and we'll know what our change is. And this is just kind of a way for us to hold on to what our remaining change is. All right, not sure what that is. like they say in Mickey Mouse. Maybe it's a surprise tool that we'll use later. All right, so if our total is $101 and our payment's $113, our change should be $12.29. I'm on board with all of that. All of that looks like the math is lining up nicely, so let's keep moving. Okay, so on the cashier's problem, the next thing we're going to do is, this time it looks like I used a dictionary. Cool. All right, so let's talk about what's inside this dictionary. The dictionary is going to have 20s, 10s, 5s, 1s, quarters, nickels, pennies, and dimes. All right, this is an artifact of Googling somebody else's code that really is efficient, and it just works well. And we're not going to worry about this right quick. We're not going to worry about this yet either. Here we go. This is what we're going to look at. All right. We're not going to do the for loop, but we are going to do this. I'm going to grab this line and let's grab this whole block of code. And let's go see if we can work with this, because this really is where you need to break the problem apart. So everything up to here, I think, makes sense to a lot of people. Some of the folks are getting kind of caught up on what to do after this point. And so this is the block of code that really does it well. Okay, so considering denomination, well, we don't actually have this denomination. But I'm going to start with the lowly quarter. All right. So it says, while the denomination is less than the remaining change. So here's a problem. Probably I shouldn't do it that way. Probably what I should do is just say denomination equals 0.25. Cool. So now denomination shows up here in our print statement. It'll show up here, here, and here. Now, this is not going to work without us setting it up first. So instead, I'm just going to do this. I'm going to do something like this. I'm going to say count equals 0. And then I'm going to come here and I'm just going to change this line of code to count. So what this is going to do, it's going to say, how many quarters are we going to give back? Let's start that number at 0. And it says, while remaining change is greater than or equal to a quarter, then I want you to go through and I want you to say, all right, take a quarter away from our remaining change and increase our count. Okay, now we need to grab this, and this will say what our remaining change is. All right, that's cool. Let's just see if this runs without blowing up on us horribly. All right, it does not like that on line 27. Let's make this a little more visible. Maybe that's the way it wants it done. Try it. Oh, that's on line 32. So let's go down and see line 32. Okay. Try it again. Yay, cool. All right, so, well, that's a big monster. It looks like our total was 2 cents and we paid $61.94. Right, so that makes sense. Yeah, all right, so there's 40 quarters in a $10 roll, and so 6 of those is going to be 60 plus another 4 quarters there plus another 3 quarters there, so 67 quarters in total. but I'm not going to count like that. I'm just going to assume it's working. But let's go in here and let's do this. Let's do after and then we'll do count plus let's do of money denomination. I'm going to drop a slash in here just to wrap it around. Okay, so let's see if that'll run, maybe make a little more sense. So I need to come in here. Oh, all right. So when it says things like, hey, file, you can only concatenate strings, not ints. It doesn't like count or denomination, so you just need to recast those. As strings. So what this is going to do is it's going to take our integer, which is how many quarters we need to hand back and how much a quarter is worth, and we're going to recast it as a string. All right, let's see here. So $36 was our total, $68 was our payment, so we need to do $32. So 3 times 40 is going to be 120 plus 8, so 128 quarters. After I give back 128 quarters, the change remaining is 7 cents. Cool. All right. Well, let's go and let's look at this problem. So I think that's what this is doing here. We are going to give back. Oh, let's get that off. Denomination. Oh, you know what? Probably what we need to do is, oh, get rid of that. I'm going to add this. So we are going to give back of, yeah. So that'll just print that off. All right. So let's see what that looks like. Run it again. Not happy. Line 36. Okay. Try that. Okay. 150 quarters, which is what we already know from here. The remaining change is 17 cents. Well, I'm going to go back in here and I'm going to get rid of these 3 lines just to see if it makes it a little cleaner. Yeah, that'll work. So 270, yeah, this seems to be working nicely. We're going to give it back 277 quarters. Now we've got remaining to do is 17 cents. All right, I'm going to skip dimes. And instead, I'll just go straight to nickels. So we'll come in here and I'm going to copy this. So I'm going to make some notes right quick, I should say. On language. Cool. And now I'm just going to change this denomination to this. And let's see if that'll run. All right. 26 bucks, pay out 29, 297 is our change. So after we get rid of that, we're going to give back 275 in quarters, and that'll leave 22 cents to give back in nickels. So, you know what? That's not a nickel. I screwed that up. So when I read this, that's when I knew I had made a mistake. And you will never fit a 50-cent piece into after you've given out all your quarters. Okay, so let's pop back here. We'll save that change because now it's a denomination is a nickel. We'll come back here, run it again. All right. So 70 bucks, we pay out 151, we got 80 bucks of change. So we're going to do a truckload of quarters. Remaining change is 16 cents. Well, that's handy because we're going to give out nickels. We'll give out 3 nickels, go from 16 cents down to a penny. Cool. All right. So this is when we can get creative. And I used a dictionary last time, and a dictionary worked really well. But you don't have to use a dictionary. One of the things that you can use is just a good old array. So what I'm going to do, all I had to do is change what the denomination was, and everything just kind of worked. So let's get rid of the second copy, and let's go in here and let's do denomination like this. Let's do denomination of 0.25, 0.05, right? And now we've got our 2 denominations rolled up into an array. Count's not going to work very well this way. And also count is going to, I don't know, it's kind of a generic. You can count a lot of things. I can count my toes, right? So how much of each one to give back. And I'm just going to make it an empty list. Okay. I'm still going to, all right, let's see. So now what we need to do is we need to put this next stuff inside of a for loop, because we need to do for each denomination that we have. So I'll do it something like this. I'll do for index in range of the length of denomination. Now, I will say this, there's probably more elegant ways to make this work, but this is where I'm going to start. Okay, next thing I'm going to do is indent this. And there's going to be problems later, but I think this little part should be able to run. I also need to do denomination of index. Okay, let's see if that little part will run, or see if I've screwed anything up. Okay, so this up at top is still working fine, considering the denomination 25 and a nickel, and then we go to here. So that is working nicely. Okay. Now we're ready to take this while loop and put it in. And I'll just take care of the indentation first. Oh, I indented one too many. Okay. All right. My brain gets like that. 1 second. Now, the next thing that we're going to look at is we're going to say denomination won't quite work anymore. Instead, we're going to have to use this now. So whenever we had denomination, we need to add of index to the end of it. So I'll just come in here, there. Print statement that's commented out, you don't really have to drop it in, but all right. So let's see if that works. I have no idea if it will or not, but we're going to try it. Count is not defined. Well, we can fix that. We just come inside of our for loop and we count. Now, the problem is we need to append that information here before we get to the bottom of the for loop. So I'm going to copy this. I'm going to paste it down here. Dot append count. All right, let's see if that did anything. Cool. So our total payment was $30.99. So we're going to give back 123 quarters. Try 204 quarters. Why would that be? Oh, $51 was our change. So 5 times 40 is 20. Looks like we had some, oh, there it goes. Not 80, 51.22. So $51 is 204 quarters. That does make sense. 22 cents is going to be 4 nickels. We'll have 2 pennies. Cool. All right. So this feels like it's working mostly, but we still have those pennies left. So I'm going to just change that right quick. And now we can get our change down to 0. Okay, so the change that we're supposed to give it is $57. So that's going to be 12 short of 240. So 228 plus 1 more quarter for the 37 cents is 229. Just guessing. Yep, 229. So that was right. Cool. Then we have 12 cents left. Yeah. 37 minus 25 is 12. And so that should be 2 nickels. And then there's 2 cents back. And that's 2 cents. All right, cool. So the cashier algorithm is working pretty well. I'm going to go ahead and shore a few things up. So we can have $100. Well, we don't need a $100 bill, but I'm going to include it anyway. We can have a 50. We can have a 20. We can have a 10. We can have a 5, we can have $1, and then we can also have half dollars, and then there is the humble dime, and then the quarter, so half dollar, quarter, dime, nickel, and penny. Let's see if all of that works now, see if I made any mistakes. Okay. So now we're going to give back no $100 bills because our change should be $84. We should give back 150. That'll take it down to $34, and 120. That'll take it to 14. A 10 will take it down to 477. No $5 bills. 4 $1 bills. That gets us down to 77 cents. And then 3 quarters. Oh, nope. We're going to give back a 50-cent piece and get it down to 27, a quarter. And then no dimes, no nickels. And finally, 2 pennies. Cool. All right. So that is essentially how you get to a spot where you can work with it. But let's see if we had any other cool printing stuff. Here's how to count back change. All right. So this one I did slightly differently. End of transaction total equals total. Print your total was end of transaction total. Now, spoiler alert, back when I was a high schooler, I actually was a cashier at Walmart. And my friend Betty Rundell is the one that taught me how to count change back. And so she's the one that taught me this nice little way of doing things. So I'm going to go back and I'm going to run this problem now. It's called the cashier problem. All right. So Python cashier problem. Okay. Your total was 44.27 and your payment was 77.93. Cool. So your change should be $33.66. And so so your total is 44.27. This is Jeremy. Sorry about that. Okay. Go ahead and share screen number 4 again. All right. So this is kind of weird. People wouldn't normally do this, but it still works the same. So if your total is 44.27, you'll get back 1 penny to make it 44.28. Then a nickel to get it to 44.33. So a nickel is cool because it makes the thing over here lined up. A dime is going to get it to 44.43. 2 quarters is 44.93. And notice how now the cents line up. So 44.93 and 77.93. So now we hand back 3 ones to make it 47.93. So now we've got the second or the third number to line up. And then a $10 bill and a $20 bill get to 57 and then 77. And so anyway, that's just a different way of doing the project. Want to do something right quick though. So let's do get add dot. So I forgot to pull, so I did a get pull. Now I'm going to do a get push again. And now the main branch is up to date. So if you want to study this in more detail, you can go to github.com, and under CS Python examples, if you go to discrete structures, exams, and exam wrong computer. All right, cashier problem.py. Or exam02 cashier.py. There it is. So this is the one that I did previously. And then this is the one that I did today. It's a little bit shorter. Anyway, the trick on this problem is don't try to do all the change at once with like a function like I did at the end. Instead, do one denomination at a time. And I picked something small like a quarter, but you can start with a 20 or whatever it is you want to do. I just picked a quarter because I knew almost always the change was going to be more than a quarter. So that's why I started there. But do it one at a time. Try to see how you can make the quarters and the dimes work the same, and then quarters, dimes, and nickels work the same. Quarters, dimes, nickels, pennies work the same. And once you can see that pattern, then you can try to extract it into a function or a loop or something of that order. So, all right, friends, I'm going to go ahead and I'm going to stop the share there. Hopefully that's beneficial. Thank you all for your time. Have a great day.